Today's episode, we're talking about semiconductors, the shortage, and the opportunities that it presents.
Don't hang up that phone. We've found what you're looking for. Welcome to the Let's Talk Cabling podcast with Chuck Bowser, RCDD. What exactly does RCDD stand for? Registered Communications Distribution Designer. Just the expert you need to ensure your cable plant performs exactly as designed. Now, send the new guy to the truck for a bucket of dial tone and the cable stretchers, while you listen to an informative program on telecommunications.
Welcome to the show where we tackle the tough questions submitted by installers, estimators, project managers, everybody in the ICT industry. We'll help connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the bell button and the thumbs up to be notified when new content is being published? If you're listening to us on a podcast platform, would you mind leaving us a 5-star rating? Those couple little steps helps us beat the algorithm to help get this information out to more people so we can encourage, enlighten, and enrich the lives of more people in this industry. Thursday nights, 6 p.m., live streams on LinkedIn, YouTube, and Facebook, where you get to submit your favorite questions to your favorite RCDD, that would be me, to get answered live. Now, I can hear you now, but Chuck, at Thursday at 6 p.m. Eastern Standard Time, I'm driving my car home. I'm not watching a video. That's okay. They're recorded, and you can watch them on YouTube, or you can go to our webpage at www.letstalkcabling.com and watch all of the podcasts and all of the recorded live streams there as well. So semiconductors, we've all seen the news reports. There's a huge shortage of microchips right now in our industry, and not just our industry, in everybody's industry. And this shortage has affected everything from cars being built to automotive industry slowing down the productions, to shortage of consumer goods, and even to getting equipment we design within our industry, such as security cameras. It's impacting us all the way around. Well, at least 2 major chip manufacturers have announced their multi-billion-dollar investment for factories to help alleviate this need. What kind of opportunities does that present for us? How's it different to do cabling in a superconductor chip manufacturing plant? I don't know these things. I'm not an expert, but I know an expert. I'm bringing back another fan favorite, Tim Kuhlman. Tim, how are you doing, buddy?
Doing good, Chuck. Doing good. Keeping busy.
How you been over there on the West Coast?
A little wet. It's going to start. The rainy season has started, but that's okay. That just means more time to stay inside and work.
There you go. Yeah, we're in our cold spell. It was actually 43 degrees this morning when we went out to take care of the animals. And for Central Florida, 43 degrees is kind of cold.
Oh, you're breaking my heart. You're just breaking my heart, Chuck.
I know. I can hear the person up in Minnesota saying 43 degrees. That's summertime weather. Yeah, but when it's 85 degrees, literally like 10 hours before that, that's a 40-something degree temperature swing. That's how people get sick, right?
Yeah.
So you heard my intro, and and you're the perfect person to talk to us about, right? So what does it take for someone to design the information communication technologies at a chip manufacturing plant?
Well, it takes quite a bit. These are complicated facilities. These are, one, making a chip is a chemical process. And so these are big chemical processing buildings where they take a silicon wafer and they etch it and they start putting layer after layer after layer after layer of resistive or conductive or semiconductive components on top of that wafer until they get something that they can saw up into little pieces and make microchips out of. So, I don't want to, simplify too much, but it's like building a 48 layer cake. And it's all a chemical process between each layer. They have to be exactly the right thickness, have the right electrical properties to it. And you're building these small, itsy bitsy little chips on this huge wafer. So you need consistency across the entire wafer. These are amazing facilities that they can do things. We're talking in the, I think the latest I've seen in the 9 to 10 nanometer layer. That's the width of these little buses. The wires, or I should say the little conductive pads in those wafers are down to 9 nanometers. And that's in standard production. There's probably stuff they're doing at the experimental level that's even smaller than that. And at 9 nanometers, what you need in the way of quality control, the environment that you're designing to, all of that has to be tightly controlled. So, and then, in how does that all tie back to cabling? Well, we have to provide a network. We have to provide cabling in this environment. It is truly an industrial environment, but it's not the dirty type industrial like you'd have in some types of manufacturing. In fact, the common term that we use in semiconductor manufacturing is we refer to the clean room. Super clean, class 1, class 10 clean rooms, because even the smallest amount of dust can just wipe out a set of chips on a single wafer. So there's a lot of things that we have to plan for from a cabling and network design as we adapt to this environment. So to learn how to do the cabling for facilities like this, it's really spending quite a bit of time working with teams to understand the environment you're designing in.
So since we're talking nanometers, I'm assuming the facilities aren't that big, or is that a false assumption on my part?
Just the opposite. So today's standards, I would say for probably memory and microprocessor, you're looking at typical clean rooms anywhere from 200,000 probably to 1 million square feet. It depends on the manufacturer, depends on what they want to manufacture and their process and what version of that manufacturing process. But then keep in mind that that's just what we call the clean room. That's the place where the business end of the wafers, the business end of the tools and the wafers, run around. The manufacturing tools themselves are fairly big. They require a lot of support, chemicals, RF generators, waste streams, gases. There's anywhere from a 7-to-1 to probably 10-to-1 ratio of support space to clean room space. So you're looking at buildings that are anywhere from 1.4 million gross to 14 million gross square feet.
Wow. It didn't register first when you said, 200,000 square feet to 1 million square feet. I thought that was the entire thing. You were talking specifically just about the clean room being that size.
Right. It's kind of like a data center. Sometimes we talk about a data center, we just talk about the white space because that's where the servers go. And that's what everybody's focused on. So with clean rooms, with chip manufacturing, we focus on the clean room, and then it's everything else, the support space after that, to make that important space functional.
There's a couple of chip manufacturers that are announcing building stuff. Does that mean they're only building 2 of these things, or there's going to be more of them?
No, in fact, just today, Samsung is the third one that announced that, they announced earlier that they're going to build another chip manufacturing facility. It's something like, if I saw my notes right, $17 billion investment to build a new factory in the US. The CEO was planning on coming over here. He's on his way over here from Korea now to take a look and talk about the deal. So, we're talking about very large investments here. Intel previously announced a $20 billion investment in Arizona. TSMC, or Taiwan Semiconductor, publicly announced a $12 billion investment. And so we're talking about this massive, huge investments. Now, most of those numbers are the manufacturing tools themselves. A single manufacturing tool can cost literally, anywhere from $1 to $5 million for one tool, and they need a whole bunch of these tools in the clean room to produce wafers in this, batch process. So, we're talking about a lot of money, but, still, if you're looking at those investments and say, manufacturing tools is anywhere from 75 to 90%, that's still a lot of money left over for the infrastructure.
Right.
Huge dollar investment. They're building in the US, partly because of probably incentives, supply chain issues, the market, tariffs. But you can bet that these companies are also building overseas. In fact, Taiwan Semiconductor has most of their plants overseas. Samsung has most of their plants in Korea, and Intel has their plants all over the all over the globe.
So when comparing and contrasting, doing the designing a cable plant for a chip manufacturer, how is it different or from a regular office environment?
Well, it all comes down to the environment. Now, some things that don't change, we still stay with 90 meters, for the permanent link. We still stay with 100 meters for the channel for copper cabling. That doesn't change at all. We're still using Ethernet networks. In fact, on the manufacturing side, and even for the building monitoring systems, facilities management system, a lot of all of those systems are on the IT network. There's some specialty control networks that are separated, but in a lot of cases, we're just pulling data from, say, from valves, pulling data from variable speed drives, from motor controllers, from a variety of different manufacturing processes that are set to a skid. It's like, say, a process that polishes water to make water cleaner. That'll come from a certain manufacturer. It already have a little programmable logic controller on it. We just provide an Ethernet port to monitor that. So all of that is pretty much the same. The difference is really when you start adapting to the environment. And that's why I would stress to anybody getting into this line of the work is you need to know your standards. You need to know your codes, because remember, our TIA standards, 568, 569, they're all built around commercial building environment.
Right.
There is no TIA standard for telecom cabling specifically for semiconductor manufacturing, or I would say in general. I mean, most manufacturing, there's TIA 1005, but it really doesn't address the environment. So some of the big differences, I would say, well, we have to provide cabling in a clean room. The cabling itself has to meet microcontamination requirements so that it doesn't off-gas chemicals that would impart themselves onto a chip in some form of contamination. So let me give you an example. That new car smell? Yeah, or even that old car smell?
Mm-hmm.
Take any smell.
Right.
Anything that you can smell, it's basically a particle.
Right.
Particle or some small form of gas, some substance. Well, that particle if it's airborne, can land itself on a chip, and if it's during the process, basically destroy the chip process. So we have to make sure that over age and over time, any of the materials that we're designing for in the clean room doesn't put off a gas, doesn't put off some type of a particle that can land on a chip and cause basically failure of the thousands and thousands and thousands of dollars it takes to produce one wafer. So that's one issue. Vibration is another. These facilities are very sensitive to vibration control. I mean, you can imagine if you're dealing with pathways down to 9 millimeter, any type of vibration for the lithography or for the manufacturing tools would cause basically blurriness on anything that was exposed on the wafer. We do have to be concerned about chemicals. There's a lot of chemicals in these facilities, whether they're specialty gases or liquid chemicals and acids, etching type solutions, and then all the waste streams. And all of those, you have to design your cabling such that in your cable plant, whether it's pathways, are you designing with fiberglass pathways in corrosive areas? Are you dealing with wireway? There's something, Chuck, I bet we don't talk too much about is
Right.
designing with wireway. And we do that basically to keep particles and other stuff from landing on the cabling that could cause the cabling to deteriorate over time.
Stepping back to the cable for just a second, because you talk about off-gassing. It's funny you mentioned off-gassing, because I'm in the process of putting up new walls for the studio here. I bought those brick-looking things, and I'm in the process of putting them. I didn't finish it yet, but I got it somewhat looking good. So I brought them into the house, and my wife, she has reactive asthma, so she's extremely sensitive to smells, and she goes, "Yeah, they smell funny." And I'm like, "No, they don't." And I put my nose up, and sure enough, and you're right, that's particles. So when you get cabling, right, is there something special? I mean, do they have to? Is it the same cable, or do they have to let it sit for a period of time for the off-gassing to expire? Or
Well, each company is a little bit different, but there are testing methods that a company will go through to test to see whether a product will meet the microcontamination requirements. And this could be a process where they put it in a chamber, say they heat it up to accelerate the off-gassing, basically capture those chemicals, and then look to see if any of those chemicals that are being released are going to have some type of an impact on the manufacturing process.
So you talk about the standards. Is there, and you know me, I love my code. Is there anything in the code, whether it's the electrical code or the building code, that could affect us, or regulations that we might have to follow?
Yes. Yeah, well, it's a chemical plant. And so anytime you have chemicals, you could be dealing with class 1 div 2 spaces. So the electrical code, Article 500, covers class 1, class 2, and class 3 environments. This is where you could have some type of a hazard that's a solvent, or some type of a hazard that might be dust. And I forgot what the third one is. So these, there's a lot of solvents that are being used, and these solvents create class 1 div 1 and class 1 div 2 spaces. And so, yes, there are things that you have to do in those environments from a cabling standpoint to make sure that those gases either don't get out of that environment, say travel up a conduit. So we're using like conduit seals. We also have to make sure that any of the conductors that we have in those environments aren't exposed such that they can cause it be an ignition source. So, we use we use specialty phones, telephones, very expensive telephones where they're referred to as intrinsically safe. They have a little class 2 power supply that's remote. And if you work the phone, you're not accidentally going to create some type of an arc, so that if there was some type of solvent buildup in an area,
Right.
that you're not going to cause basically the plant to explode.
So some of the chemicals that they're using are explosive?
Sure.
Oh,
Well,
wow.
solvents, we call it IPA. It's not Indian Pale Ale, it's isopropyl alcohol. Think of rubbing
Indian Pale
alcohol.
Ale. Is that what you use to clean fiber with? Indian Pale Ale? I'm going to remember that one.
No, I use that as a digestive.
Of
But
course, medicinal only.
only,
Gotcha.
but isopropyl alcohol, which we know in our own households as rubbing alcohol,
Right.
they will just use a very high concentration of it, say 99%, 95% IPA, and they use that as a cleaning agent to clean and wipe stuff down. That's a very common alcohol, but it's also a solvent, and in high concentrations, it can be explosive. And that's just one sample, but there's silane. There's a gas which is pyrophoric. Any type of, and silane just is exposed to air, it'll spontaneously combust. So that's just 2 chemicals I've mentioned. There's others. Another one is water. These facilities use a tremendous amounts of water, and what they need for processing is called ultra pure water. And the water is so pure, they measure it for resistance in the megohms.
Wow.
So there's absolutely no minerals that could accidentally attach itself to a wafer. Incredibly clean water. Very dangerous if you're the purest of pure water, and yet if you were to drink it, it'd probably kill you. It definitely would dissolve your teeth, as it wants to attract all those minerals.
Oh, gotcha.
Think of water.
If it's really pure, how's it going to kill you?
Water is an incredible solvent. It's probably the universal solvent, right? On the planet, it dissolves rock, right? It dissolves iron into it. You ever had drink water that tasted like salt? Yep. Which down in Arizona, it tastes like salt. Some places it tastes like iron. Other places it has a really high mineral content, or limestone, or all that scale it leaves in the coffee pot. Well, that's because all those minerals have dissolved in the water. Water is incredibly reactive. Makes it for a really good cleaning agent once you get it purified. But in the regular building, once you're working with it, it's a corrosive. And you have to make sure that if there's any kind of leaks or any type of exposure to any of that ultra pure water, you're now dealing with a corrosive environment.
I never knew that water could be classified as a corrosive. That's interesting. So let me ask you this. So because they're manufacturing semiconductors, and I'm assuming high tech, right? Is Is it the same cable? Cat 5e, Cat 6, Cat 6a? What is it different?
What I see mostly out there is Cat 5e and Cat 6. Uh, we're not talking about, from a manufacturing standpoint, we're not talking about huge amounts of bandwidth. We are seeing still Cat 6a when it comes to wireless access point. I would say that is more driven by the wireless access point as the end device than anything else. When it comes to the manufacturing tools, the facilities management systems, and we're talking about probably a dozen to 18 different type of systems we're connecting to. We're in an office environment, you're connecting to what, 4? All those systems, we're not talking about high bandwidth. We're just talking about a lot of connections. So, and the other thing as I see is a lot of unshielded cable. So these are incredibly noisy environments from an RF standpoint. They literally use RF generators as part of the manufacturing process. You got a lot of confined tools all next to each other in the sub-fabrication level where we have all our cabling. And, we're not using shielded cable. The cabling itself is surprisingly robust for high EMI environments.
Gotcha. Yeah, because a lot of it depends on the frequency that interference is coming from. Because unshielded's got twisted pairs, and those pairs are twisted to reduce the EMI. So it's
And it does it quite well. And for semiconductor manufacturing, I would say I don't see a lot of shielding. Where I do see shielding is when you start getting into say appliance or automotive manufacturing. And so there, in those type of manufacturing environments, you have welding or spot welding.
right.
And those EMP pulses from the spot weldings can cause a lot of interference for the cabling, but don't typically have that for semiconductor.
Yeah, I can imagine that. So let's go back to the clean room for just a second, right? So you said it could be anywhere from a couple 100,000 to 1,000,000 square feet. Do they have telecom rooms inside of them?
No. In fact, they refer to these as ballrooms. If you were to go online and take a look at a state-of-the-art clean room, what you would see is this massive space with no columns, typically no columns, and it's just pure white all the way across, getting ready. And they might have an area that has a lot of yellow lenses instead of the regular white fluorescent lenses. But for the most part, it's just an open, clear ballroom. Everything in that clean room is 100% maximized to get the most number of manufacturing tools. So once again, so that's a deviation from our commercial building standard that says you need to put a comm room on every floor. So literally instead what we do is we put all the communication rooms and cabinets, typically they're cabinet environments for the networking, all underneath the clean room. And then we serve up through into the manufacturing tool space. So there's
when you say underneath, you're talking about underneath the raised floor or underneath or is it the floor below and they're doing core holes up? What do you mean underneath?
So this is where I would love to have a diagram to show you. So what you have, it's a multi-story building. And you'd have the fabrication level that holds all the manufacturing tools. Below that level is what we call a subfabrication level. And this handles most of the distribution to the tools that are sitting above. And the tools are now so big that only the business end of the tool will be up here. And then through umbilical connections, the rest of the remaining parts of the tool will be below. And so you can think of it as a floor level where the tools are stacked. There will be a raised access floor. That's fairly common for local distribution of utilities. That could be anywhere from 3 to 4 feet tall of a raised access floor. But we'll use typically communication rooms or cabinets below the subfabrication level. I've also seen designs where in the clean room interstitial level, that's a room a level above the fabrication level. That's another way we can distribute from the top down above this is typically called interstitial or the fan deck level. And then, so below the subfab level, there's even more utilities. So your big electrical plants and substations and big mechanical ducts and pumps and waste collection, they're even below that. Mm-hmm. So you're talking about a multi-story building just to make for this thin layer of clean room to maximize the manufacturing space.
Gotcha. So you said you wish you had a diagram. If you have a diagram that that'll fit like a regular 1920 by 1080 screen. Take a screen snapshot of it, and I can put it in the video and superimpose it where you're talking. That's easy to do. That's easy to do. And I can tell you're a code guy because you said interstitial. Us code guys all talk alike. I'm telling you. I'm telling you. So let's talk about microcontamination from the telecom. You talked a little bit about the cabling. Is there any concern with patch panels and patch cords and any other telecom products?
So what we try to do is we try to design the communication rooms themselves so they're outside of the clean space. And that's just from a logistics of trying to do maintenance. Anytime anyone goes in through the clean room, there's a protocol, and they'll typically be in a complete clean room suit. So you're talking about a white Tyvek suit, you're talking about gloves, hairnet, booties, so that you're not bringing any type of contamination into the clean room itself. And if you had to do maintenance in all the comm rooms, and said when you look at 1.4 to 14 million square feet, there's a lot of cabinets or a lot of network centers and comm rooms to deal with. You don't want to have to go into a clean room environment any more than you have to. So we try to get those rooms as far away from a protocol space. Even the subfab, which is clean, it's not as clean because of the airflow. It's on the downhill side of the airflow, and therefore it's not the air before it gets recirculated will be filtered before it gets back to the tools. Even there, you have to put minimal amount of gowning on, which isn't as bad as if you had to go in the clean room proper. So we try to get those rooms as far away as we can, but yet we're still limited to 90 meters cable distance. And even in an industrial environment, you can't break that.
Right. So I guess when it comes up through the floor, I'm assuming, are they fire stopping that, or are they sealing it with some other types of means, or?
So that's another thing that I would say any ICT person should understand is the environment you're designing in. So that goes back to the building code, and microelectronic facilities or semiconductor facilities are typically an H occupancy. I don't have it memorized off the top of my head of which of the H's. I can't remember if it's H4, H5. But anyways, if you look in the IBC, you'll see that there's an H occupancy. And because of that H occupancy, you can do certain things in that environment because of the way the environment has already been designed for, say, fire protection, that you couldn't do in other environments. So it wouldn't be uncommon to have the fabrication level and the level right below it to be a call flow through, where the air is literally flowing from one level to the other, and they use a waffle type slab. Think of a floor that's designed like a Belgian waffle, or one of those Eggo thick cut waffles. By the way, those are incredibly good.
You're making me hungry.
Knock the little hole. Yeah, well, think of that as a floor structure. Knock little holes in between all the webbing, and you can run all your utility through that webbing, and yet the waffle itself has a tremendous amount of structure when it comes to support and vibration to support all the manufacturing above it. And then it's, as we go through the other levels, there would be rated floors, but once again, because of the H occupancy, even though the floor is rated, because of all the fire protection in the building, you wouldn't necessarily have to use fire stopping in all cases. The buildings are so big that typically horizontally through the building, we do have a lot of fire stopping. And sometimes those are anywhere from 2 to 4 hour rated walls. The 2 hour rated walls are are something that we're familiar doing with. When you start getting into 4 hour rated walls, that is a engineering challenge when it comes to how you fire stop that, how you seal it, and what type of, how many holes you can make in the wall. So that always becomes a challenge. So yeah, every building has its type. You got to learn what the type is, and then you basically adapt your design to that building type.
I would think with a 4 hour wall, you're going to be leaning more towards a mechanical type of a system than a non-mechanical system. Like on the ships, they have the mechanical systems that there's a bolt on the top, and you unscrew it, and then you take out the little wafers and you peel off the layers. You put your cable in, you put the piece on it, and you tighten it down. It compresses it because it's also explosion proof, right?
Right. So what you just described, I don't want to name drop, but what you described as a product made by Roxtec.
Right. Yes, I couldn't think of the name. I used to have one in my Bixie lab when I used to be an instructor many moons ago for a cabling contract. I used to have one in my office. I just couldn't remember the name on it.
It's an excellent
Um,
product, and I have used those in those type of facilities before.
Gotcha. So you mentioned vibration, and when we're talking about microchips, I did a tour a couple years back. Well, probably more than a couple now, but I ride a Harley, right? And so I was doing some classes through Central Pennsylvania, and I found myself one of the classes canceled, and I had a day with nothing to do. So I called my boss up and said, "Hey, boss, do you mind if I take the day off and go to the Harley plant?" He said, "Yeah, no good problem." So when I was walking the Harley plant, they do have the big machines and everything, and I always wondered, how do they make, not to get too technical here, but I ride what's called an ultra classic. It's got the big front fender on that thing. And I always wondered how they made that thing. And when you take the tour, they show you, they got these two big presses, and they put a piece of sheet metal in there, and those things come down, and bam. I mean, literally, the floor of the plant shakes. I mean,
Yeah.
and then when it come out, there's your fender. And then they just cut
Yeah.
off the excess pieces, and then they, prep and paint and do whatever else that they do with that. But semiconductor, how much vibration is that? I mean, realistically, and would this be a good environment to practice here's your acronym, me and the acronyms, right? MICE cabling.
Well, we don't use mice cabling. Like, you're referring to like an IP65 or an IP44 or something along those lines of classification. That would be more common in, I would say, a dirty industrial. So, some automotive manufacturing and other type of product manufacturing would probably use something like an IP or a mice system. Here, the vibration has to do with the tools themselves can't be exposed to any vibrations. A simple motor, a simple 5 horsepower motor, if it wasn't isolated, is just going to cause vibration from that subtle imbalance, either in the rotator or the coupling or something. It's going to cause a small vibration when it rotates. And if that vibration, as small as it is, can get transferred to a manufacturing tool that's trying to etch a 9 millimeter
Right.
line.
Okay, I got you.
And
I got you.
that line starts doing this, and it starts making it blurry.
So the vibration is not necessarily a concern that's going to cause intermittent connectivity with the cable plant. It's
Not
more
at
of
all.
the precise nature of the manufacturing that the vibration causes the problem.
Right. There's very little, other than when they have a chemical line break. There's very little that really affects us. I can think of one case where we have all this. We basically run cable tray in rows and rows and rows underneath the clean room to distribute our cable, and then we come out of the cable tray, pop up through that waffle slab to a manufacturing tool. And in the early days, we used to design with a solid bottom cable tray with a cover on it, with the intent that, okay, if there's an EMI problem, and we're talking about the early days, we're talking about the early 90s when we still had quite a bit of RS-232 before it was all 100% Ethernet. Well, with RS-232, you do have to be considered with EMI because it's an unbalanced signal. Right? Ethernet's all balanced signal now, so it's not so bad. But they designed all this solid bottom cable tray. And they didn't always put the lid on it because as they're constantly adding cables for tools, they wouldn't put the lid on it. And they said, well, if we get into a problem, we'll put the solid lid on it later on. Well, they did have a chemical spill one time, and amazingly enough, those solid bottom trays acted like a canal and took that liquid chemical, ran it like a canal right to the IDF cabinet, and basically filled the IDF cabinet with chemicals, which pretty much wasted the cabling and destroyed the IDF cabinet.
It had a negative impact?
It had a negative impact. There was a learning moment there, Chuck.
for somebody, and a very expensive learning moment too, right?
New line item on the lessons learned.
There you go. There you go. So I want to take another step back, because you were talking about the amount of chemicals and harsh chemicals that they're using and stuff. And you mentioned, the class 1, division 1 and stuff. Yeah. Just a very high level. Can you just kind of give us for those who listening may not know that, and I'm one of them because I'm not. What's class 1? What's division 1? What does that exactly mean?
So if you're looking Article 500, you'll see 3 different classes of potential hazards. These are hazards that can cause spontaneous combustion. So One is vapor, one is dust, and I apologize, I don't remember what the third one is. Then there's two divisions. So the first division is that there's solvents typically exposed on a routine basis. The second one is that any type of solvent exposure or any type of exposure of this hazardous material would be inadvertent. It could happen, but it would be inadvertent. So for example, think of a laboratory where you have this laboratory hood, and all day long, a laboratory technician is mixing chemicals and stuff like this, right? There's always chemicals exposed. They're always mixing chemicals. Inside that hood area itself could be a class 1, division 1. Say they're dealing with 99% IPA or isopropyl alcohol. So inside that hood area, they could always be a class 1, div 1. Now, outside, they might have a large, 5-gallon drum of IPA that they refill their little wash bottle with. Whenever they fill that wash bottle, there is a chance that some of that stuff could be spilled. And so that creates an area, what we would call a class 1 div 2 space, where there could be an exposure. And you have to account for that. And so anyways, it's just that in a fabrication facility, that's done on a much larger scale because the quantities of solvents and the quantity of chemicals.
So what are some of the key takeaways that someone designing this, or maybe an installer actually installing the cable, what are some key takeaways that they need to
So the cabling installer has their big challenge in that everything that goes into the building has to be clean. One, they're not going to be able to put on deodorant that morning. They're going to have to take a shower and not use deodorant. You're not going to be a smoker, a heavy smoker. You're not going to be able to wear any colognes or perfumes. You can't take any organic materials into the clean room. You can imagine the downside of somebody taking chewing gum, sticking it to the wall, and then having that chewing gum outgas over the next umpteen years. So there's no food products taken in. And then any product that you take in that's going to be related to the clean room is going to be wiped down typically multiple times. Simple things like a drill motor, just a simple drill motor, you're going to have to take clean room tape and tape over the vents on it so the brushes don't put carbon particles in the air when you're working with it.
Wow.
There are certain areas where you have to be concerned with your tools in that if they have a certain process, that process can actually, the particles attach to your tools. And if those, and they're typically some type of metallic process. And so that metallic process attaches to your tool, and then you take it to another area, you can cause cross-contamination. So there are situations where you can take your tool in, but you can never take your tool out unless it's to dispose of it. And by the way, drills, when you cover up the vents, they don't last very long.
I was going to say that how do they keep cool? Because they'll burn up. And it's funny you say
They
that
do.
because my DeWalt drill was smoking last night. It was just, there's something, the brush got going bad in it or something, I guess. And when I was putting up the wall, it was putting off some smoke. And as soon as you said that, that's exactly what I thought about was my drill was smoking. I probably wouldn't be able to take it in if it's doing that.
So for an installer, there's quite a bit that has to, you want to think about how can I pre-assemble stuff? How can I wipe things down? How can I clean things so that I'm minimizing my amount of time in the clean space? And so whether that's bundling cables, wiping them down, bundling them, putting them on reels so that you can, as opposed to pulling individual cables, all the type of things you want to think about so you can minimize your time because it's very expensive. Think about it. You're going to spend at least, if you're good at it, you're probably going to spend at least 10 minutes getting gowned up.
Right.
You're going to go work. You may want to take a break. You may have to take a break.
You can't take your lunch in there.
No.
You can't take your lunch in there, so you got to come out for lunch. So you got to de-gown, go eat, and then come back in and re-gown to go back in.
And in some cases, you can't even take your cell phone in there. So sometimes you can't take your cell phone in because it's not the right type of phone and they're EMI. In other cases, because of industrial espionage, A manufacturer is not going to allow you to take anything that has any type of recording device in there. So you're completely isolated other than the phones that we put in the facility. So if you need to communicate, say you got a sick relative you're keeping an eye on, it can hardship working in the clean room environment. And so you want to minimize the amount of time you're in there. Very expensive from a construction standpoint.
Oh yeah, that's a lot of downtime. A lot of downtime. That's got to be estimated in the project. So that's assuming that's how the designers got to think about that as well. I mean, it sounds like there's a lot of similarities, but there's a lot of stuff that's not that you're not going to find. And to me, the downtime as an estimator is going to be the biggest one, because that's usually an unknown. How do you estimate how long it takes to put on a gown, take off a gown? How many? Do they have bathrooms inside the clean rooms? If you have to go to the bathroom, you have to go back out.
Yes, you do have to ungown in most of those and go back out of the clean room and then go back in.
Do they? So when you ungown, do they throw away the old gown, or
No.
does that?
All depends. There's two different levels of workers. There's those that work in there. I should say three levels of workers. There's those that work in there every day from a manufacturing standpoint. So they'll have the nicer equipment. They'll actually have ventilated hoods that have a little fan on it to circulate air to make it a little bit nicer to work with. Then you have the full-time construction workers in there that are constantly building things. And so they may use their clean room suit for, say, 4 days, 5 days in a row, which they'll hang it up on a hanger in the gown room and then reuse that. And then there's, people like me that probably go in there just once to do an inspection or a site walk. And then I don't need to go in there for another month. Then it's a one-time use that I put the clean room suit on, glove up, go in there for as little amount of time as possible, come back out. And then all that stuff goes into the hamper to be washed.
Wow. Interesting stuff. Interesting stuff. Every time you come on my show, you teach me something new. Every time. That's why I love having you.
Well, I appreciate being here, Chuck. It's a lot of fun.
We definitely appreciate having you. So for next time, remember everybody, if you get the opportunity to do some cabling in a semiconductor facility, there's a lot of extra hoops that you're going to have to jump through that's going to cost you. So it's going to take time for that. Till next time, everybody, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.